Hi, my name is Vinu. Our team is from the Advanced Real-Time Simulation Lab, Carleton University. We developed a COVID-19 game simulator called Don't Catch Me If You Can. It is a serious game and integrates simulation data with BIM models. Our team has diverse expertise in building information modeling, software and web development, interaction design, visual analytics, modeling, and simulation. We used the Guangzhou restaurant, China, as a case study and developed a discrete event-based model. The restaurant was modeled using Autodesk Revit. Autodesk Forge is a web-based API, and it was used to integrate the COVID devs model with BIM. The BIM data was extracted from Forge Viewer, and we used Cadmium Simulator to run the devs model. The simulation results is visualized using Forge Viewer. So the base model was developed for the breathing scenario. It considers that an infected person releases 33 viral particles per minute, and if the non-infected person's threshold reaches 1,000, they become potentially infected. We modeled for vents off, that is uniform airflow, and with vents on. The visualization shows the aerosol concentration in the room and the human conditions. The aerosols are represented by yellow for low concentration and red for high concentration. The human conditions have 4 types: susceptible, exposed, infected, and potentially infected. The light blue represents susceptible. Anyone in the same room as an infected person is susceptible. Exposed is dark blue. Anyone within the close proximity to the infected person and exposed to a higher concentration of aerosols is exposed. The infected person is black. White represents the people who inhaled 1,000 viral particles or the threshold value. The Forge Viewer gives an option to see the data for the mask on and mask off. This video shows the vent off scenario. In this, the airflow distribution is uniform. We introduced 2 infected persons at different locations to observe the spread of the virus. The area at the left end is very compact and potentially infected occupants are high. We implemented the model as real-world gamification for designers, building facility managers, and other industry stakeholders to make a risk assessment, as this will give them the end-user experience. We implemented large data, mapped the camera coordinates to the simulation data coordinates, integrated gamification, and explored different visual color schemes. Why? It's a real-world application. The building is real, and the spread of the disease follows real-world model. It is not an animation. It is a serious game. Second, it's a risk assessment and decision-making tool. For example, it would train the building industry practitioners to improve ventilation or spatial design by modifying the BIM. And also with the help of IoT, we can do contact and spatial tracing. This is the logo for the game simulator, Don't Catch Me If You Can. Omar is going to give a demonstration on the game.
In this demo, we have our game reset button, our mask on game mode, mask off game mode, and legend to indicate viral aerosol concentration. And then on the right, we'll have a mini map that will let us know where we are as we play the game. And then on the left, we have the game overview panel to tell us our current health, time remaining, and the tasks to be completed. First off, we'll start by fixing the vent, make our way down the hallway. We'll have to go through the viral aerosol and give the vent a click to consider the task done. But to avoid losing any more health, we'll take an exit that doesn't have viral aerosol. And let's go ahead and watch the conference to complete that task. But you'll see that there's viral aerosol we can't avoid, so we're going to take quite a few hits on our health. And then we'll watch the conference, consider it completed, make our exit. We're going to continue to lose health because there are no alternatives to where we exited from. Now let's go to class and sign ourselves in so we can win this game. Now you'll notice that we finished with our health at 78% and almost 4 minutes time remaining.